Okay, so make sure, those of you who are watching this online, make sure that you have watched the first part of this video. It's a separate video, introduction to slope fields, and then this is our pre-response samples. So make sure you go back and watch that first one first. Okay, so here's the function, dy dx, and you can see it's a little more complex than some of the ones that I showed you before. And in this case, they actually want you to physically draw the slope fields in, all right? Since it's a little more complicated, you might want to do a small table to get started, or a big table, whatever kind of thing you want to do. I would encourage you on these tables to sort of set one thing to be the same and only change the other one. So I'm just going to start at the left side of the table, which is at -1. I'm going to let x be -1, and I'm going to do y equals 0, 1, 2, and 3. And whether you put it in a table or not, that's just if that helps you, okay? If you don't need to put it in a table, if you can see this part in your head, then that's fine, okay? So plugging in -1, you'll notice here x squared, -1 squared is 1, so it really is not playing a big role in the slope right here. But when y is 0, the slope is -1. When y is 1, the slope is 0. When y is 2, the slope is 1. When y is 3, the slope is 2. Okay, and you can go ahead and create that table, repeat that table for when x is 0 and when for x is 1. Show whatever you need to show to make this clear for yourself, because it isn't hard, and you have plenty of time to do it. There's nothing wrong with making a nice table with all of your information. So 0, that's even easier, because when x is 0, what are all the slopes? Yeah, so this is for all of them. Slopes are all 0. Okay, we'll put that right in. When x is 0, all my slopes are 0. You'll notice that they did not put a dot on the origin, or did they? They did. I just didn't put one on here. Okay, so there we go. All the slopes are 0. And then another one where you go back. I've run out of room here, so I'm just going to change this to +1. And -1, 0, 1. You know, I get exactly the same thing I got the other way around, yes? Because whether x is +1 or -1, it doesn't make any difference, okay? In this particular one, because x is squared. And then you need to draw the slopes in there. It needs to be clear which slope is negative, okay? It needs to be clear that these slopes are negative here, and the same. And then there needs to be a differentiation in this slope and that one. It needs to look like it's steeper. They're not going to say, oh, that's not a good slope of 1. That's not what they're going for. They're looking more for just relative. And like I said, this is what, 12 points? That's about all they ever do. Okay, I've seen them do one with only 9 points before. Okay. Easy enough? Okay. The second question. When are the slopes positive? There's more words there than that. I shortened it in my mind. Well, the slope field is drawn at only 12 points. It's defined everywhere. Describe all the points for which the slopes are positive. And if you take it down to 2 words there, when the slope's positive, it makes it easier than when you've got all those other words in your head. And if I gave you this question, and there were no slope field on the page, and I had told you that this is the slope, how would you figure out whether the slope is positive? Where is the slope? Positive, yes? So first you'd say, where is it equal to 0? And this is always positive right here, yes? So all I really need to know is where is this positive? Okay, and that's a 2-sentence thing, and it looks like that's going to be so scary because it's multiplying here and there and blah, 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 and it comes down to just writing down slopes are positive and changing that to the language of calculus. So anytime any point whose y coordinate is greater than 1, okay, the slope is positive. Okay, some people did that by looking at the picture they had drawn. Some people did it algebraically. It's only worth 1 point. Okay. All right, and here is the meat of these, because these questions tend to be 1 or 2 points for the slope field, another 1 point question, occasionally it's a 2 point question, and then the last question is worth 5 or 6 points. Okay? And it is a problem where you have to separate the variables. The keywords here are particular solution. If you'll read the language of the problem there, it says find the particular solution. Yes? Okay, and then it will give you a point, and they'll call it an initial condition. All right? So what these problems involve usually are slopes that have both x's and y's in them. So when we have a derivative that has both an x and a y in it, do you have any clue what you might need to do first? These are the separate the variable problems. And this is where they say in the grading scale, this is a 5 or 6 point question, 0 out of 5 if they don't separate the variables. 0 out of 6 if they don't separate the variables. You have to recognize that you're going to separate. Your separation at this level is always done by multiplying and dividing, never by adding and subtracting. Always done by multiplying and dividing right now at this level. We're going to multiply both sides by dx. Just a heads up that that's not always legal, okay? But it is for everything we're doing, okay? And then what piece of this do I need to stay over here with the dx is dx squared. So I need to get rid of the y plus 1. So I'm going to divide both sides by y plus 1. I mean y minus 1. Do you see how I accomplish that by multiplying and dividing, not by adding and subtracting, okay? And everything that's got a y in it is over here, and everything on the left, and everything that's got an x in it is on the right. Okay? All right. So I need to solve this for y, and that means I'm going to take the antiderivative of both sides of this problem. Just like in pre-algebra, you added 1 to both sides, or in algebra 2, you took the square root of both sides. Okay, the reason that we could not do this before is because on the left-hand side, this is a substitution question. Okay? So on the left-hand side, you're going to think or write down u equals y minus 1, du equals 1 dy, or just plain old dy. So we have the integral of 1 over u du, yes? Right? Okay. If there were a 2y or a 7y, we would have another constant that would pop in there that we'd have to keep up with. So when I take the antiderivative of 1 over u, what am I going to get? ln of u. Yes? So it's going to be ln, this left-hand side, this thing right here is the ln of the absolute value of y minus 1. Okay? No matter if this is a y plus 3, a y minus 7, as long as this piece is just a plain y, this is what's going to happen. If it's a 2y, then you're going to have to make sure you're careful about that coefficient. Okay, I'm not going to put the constant here because I'm going to get a constant on the other side, and I don't want the 1. Okay, I don't want to have a 1 constant. The other side is just plain polynomial anti-differentiation. So on the other side, I get 1/3 x cubed, and you need to put a plus 2. Okay. Okay. If you were to look this up online, you will find some people telling you to rearrange this now. Mrs. Farmer will tell you to go back and use your initial condition now because she thinks it's easier. Okay? But if you were to look up how to do this, you will find some people saying to solve it first and then do the initial condition. It's also correct. Okay? So I'm going to plug in 0 for x and 3 for y and see what happens. I got my constant, and my constant is the natural log of 2. Okay? It's just some number. So I'm I can write my statement again. The ln of the absolute value of y minus 1 equals 1/3 x cubed plus the natural log of 2. However much this problem is worth, usually at this point you've got everything but 1 point. And the last point is to get it rearranged. Because what did they say to find? It says find a particular solution, but what does it say after that? Y equals. All right, and does our statement say y equals? Okay, so let's see if we can crunch. Sometimes this piece is worth 2 points. We need to crunch through getting this into y equals form. Alright, so there's a y wrapped up inside an ln. So how do I un-ln something? Exponentiate it, yeah, e to the, I always just think of it as rewriting it in exponential form. So this is gonna be e to all of that stuff. Let me do it the other way. It's gonna be y minus one, the absolute value of y minus one equals e to all of that stuff. Now here's a little algebraic thing that can be helpful. You know how if I said e to the 2 times e to the 3, you could say that's e to the 2 plus 3? Yes? So you see that plus right there? Okay, so you could take that and make that into an e to the 1/3 x cubed times e to the ln of 2. And here's a thing that will show up on some multiple choice places. What is e to the ln of 2? It's 2, okay? And if you don't do it and it's free response, they don't care. But if it's a multiple choice, it's probably going to be done like this, okay? All right, if you left it just like this and did everything else that we do, and you left this instead of this, then they don't care on free response, okay? All right, so what's the next thing I have to get rid of? The absolute value. How do you get rid of absolute value? Or, like when you're asked to solve this right here, what's the answer to that? Long time no see, huh? 2 or negative 2, plus or minus 2, like that. Yes? Okay, so we have to put a plus or minus to get rid of the absolute value. That's how you get rid of it. So this is going to become y minus 1 equals plus or minus 2e to the 1/3 x cubed. And then you're going to add 1 to both sides.
You have both where you can get like y minus 1 times negative 1 and then the other y minus 1.
Yeah, you can put the plus or minus on the left side or the right side. It doesn't make any difference, which is what you're saying.
Yes.
Like, I've always just put it on the right side, but it doesn't matter, okay? Now, there's one last little tricky thing here, and that is that when you put plus or minus in, you no longer have a function, okay? So, you have to decide, is it plus or is it minus? Which one of them is it? And that answer is pretty much gonna be based on the fact that they gave you a point. And what point did they give you in this problem? In the first quadrant, okay, 0, 3. So when you put in 0 right here, when you plug in the 0 right there, e to the 0 is 1. And in order for us to get 3 out of that, is it gonna be the plus or is it gonna be the minus? It's gonna be the plus. And sometimes they've decided that they're not gonna take it all points for that, and sometimes they've made, if you get one of them, plus or minus, then you get everything but 1 point, and then the correct one, then you get stuff. Okay? That's how these problems work. Okay, that's a separated variables problem. Okay? All right, let's try the next one, which is 2005, number 6. These are the easiest ones to find. I have seen a free response packet, a free response set of questions where there was no slope field, but they still had to separate the variables question. Okay, so even if they put the slope field in the multiple choice, then the separate the variables question was still on the free response, and they just gave it 3 different questions instead of 2. Okay, so number 1, can you draw a reasonable slope field? Okay, looking again at where are they positive, where are they negative, where are they 0? Slope equals 0 if?
X equals 0.
X equals 0.
So do you not draw one of origin?
Correct, because slope is undefined. Where? Yeah, not just at the origin.
Y equals
So y equals 0. So you can notice they didn't put any dots on the x-axis. I think they kind of don't take off for that, but don't put on so there's no dots. Okay. and you've only got, 8 more points to fill in, yes? Over here in the first quadrant, when x is positive and y is negative. No, when they're both, sorry, both of them are positive, your slopes are going to be negative. And so, this is 1, 1, that slope is negative 1. And then 1, 2, no, that slope is negative 2, isn't it? 1, 1, the slope is negative 2. And 1, 2, the slope is negative 1, so it's less steep as you get up higher. Okay? I usually only make these worth 2 points, so they are a little bit generous, but if anything's positive where it ought to be negative, you're gonna lose it, okay? And, if they're, probably if you had 3 out of the 4 quadrants right, they'd probably give it to you, okay? This one over here is less steep here and more steep here, and that sort of pattern. Okay? So the actual creation of the slope field is not difficult. You just sometimes need to slow down, all right, if they're a little bit more complicated. Okay, I'm guaranteeing to you, if they don't put this, draw a slope field on the free response, then there will probably be 2 of them on the multiple choice, okay, and certainly 1. This next part, the question usually asks you to do something with some information. And it may or may have something to do with slope fields, or it may not. I mean, what is it they've asked you? I don't care that this says blah, blah, initial condition, blah, blah, blah. What they ask you to do?
An equation for the line.
Here it is. Write an equation for a line. What do you always need if you are supposed to write the equation for a line? You need a point, and you need these slopes. So then you look at what they gave you. They gave you a table, did they give you a function, did they give you a slope field, what did they give you? Okay, well they gave you a point, what point is it?
1,
1, negative 1. How am I supposed to get the slope at 1, negative 1?
You use the differential.
You use the differential equation, you plug in 1 and negative 1 and you get the slope out of it, okay? And that slope is 2. Okay, so there you go, you got your equation written, it is y equals, no, it is not, it is y plus 1 equals 2, that's x minus 1.
But now you have to use it to approximate.
That's correct. Now, this was one of those, they probably gave you 1 point for this, and they said use it to approximate this. This question's gonna be on the exam somewhere. It could be anywhere. Any of these questions I've given you, it could pop it in there. It just means to plug that in to this equation, okay? And you're not gonna have your calculator, so it's gonna be not too hard to do. So y plus 1 equals 2 times 1.1 minus 1, and a little bit of arithmetic later. Negative 0.8, right? Okay. I cannot tell you what the second question is going to be. If this is the format of one of the questions, slope field at the top, question B, and then the separate your variables problem at the bottom. It could be anything. Just try not to look at it like, oh no, this is a separate the variable. No, just read it. When is the slope 0? When is the slope undefined? Write the equation for the tangent line. Okay, when is this increasing or decreasing? So then figure out what you need from there. Okay, so if you read question C again, it's the same thing we did on the last problem. We have to separate our variables. Okay, and we're going to do it by multiplying and dividing. And this one's a little bit easier because you can just cross multiply. Y'all see? Cross multiplying gets easier. Don't do it by adding and subtracting. I'm not going to tell you that there is no time that that's appropriate, but I can't think of a time right where it's true. And as soon as you've got it separated, then you're going to take the antiderivative of both sides. And this time I did not get a 1 over something. It's very common to get that. If you when you look through the packet and you find the other 6 questions that are like this, like 4 out of the 6, you get a 1 over y or 1 over y plus 1. I love to put it in right here. But this time we're going to get just both polynomial. So on the left side it is 1/2 y squared. And I'm gonna say again, you can put the plus c either place, it doesn't matter. Okay, if you put the plus c on the left, and you get c as -2, then if I put the plus c on the right, I'm gonna get c as +2. And the relationship will end up being the same, okay? And this one is the next square. Okay, so a point again, they're going to say in the scoring guides, 0 out of 5 or 6. Sorry, now you have to sharpen pencil. That's right. 0 out of 5 or 6 if you don't separate the variables. And if you don't put your plus c, then you're not going to get any credit for the further work. The plus c has to be the recognition plate there. Okay? They gave me a point. What point did they give me?
Oh, 1/1.
I'm -1. F of 1 equals -1, however they gave it to me. I like to do it right here before I rearrange. I'm also particularly fond of plugging them in backwards. I like this one because it makes the point of that negative being inside versus the negative being outside, not messing with arithmetic up. So this is 1/2 equals -1 plus c, and c equals 3/2. Okay? Good? Okay, so your last bit, your last point, or sometimes two, is for them getting it into y equals formula. So multiply both sides by 2. And then what do I have to do? And what do you have to remember to put? Plus or minus. Their favorite thing is to get that plus or minus in there, either with the absolute value, the element of the absolute value part, or by having this being a y squared and you solve for it. And if this is not a function, it has a plus or minus. So now you need to go back and take a look at your point, which is 1, -1, yes? And when you plug in 1 right here, this is 1. How are you going to make your coordinate, your last coordinate, be negative? By choosing the negative right there. So the correct answer is this one. Okay? I find these questions to be very doable as long as you've worked 5 or 6 of them before you go sit into that exam. Every once in a while they throw something wonky at you. I've told y'all that there's a wonky question somewhere in there that I can't prep you for, and sometimes it's on this one. Okay? But if you'll look through your package, you will see that I think every one, 2004 and B, 2005 and B, 2006 and B, I think of the 8, I think 7 of them have this question on them. Okay? So you've got plenty of problems that you can practice, and it's not very hard. Yes? Okay? And we'll stop. Okay? Okay.
Is it?
Well, did I stop it?